Hello students! In this video we are going to be unpacking the G7SOL. This G7SOL is all about similar triangles, and just looking at it you can kind of see it's a lot like the G6SOL if you watch through that series. G7 says the student given information in the form of a figure or statement will prove two triangles are similar. This is all about similarity. And we need to be able to use these three methods: algebraic methods, coordinate methods, and deductive proofs. Now, you can breathe a sigh of relief. These proofs are not the two-column proofs that we saw in G6, the standard on congruent triangles. These proofs are much lighter, so we'll be diving into that in another video. Let's get a couple refresher notes here. Make sure you remember all the important information about similar triangles. So in congruent triangles, there are 5 ways to prove congruence. But in similarity, there are only 3 ways to prove similarity. And that is called the AA similarity postulate, standing for angle-angle. And in this proof, it says if we can prove that 2 angles of one triangle are congruent to 2 angles in another triangle, then those 2 triangles are similar. We've also got the SSS similarity theorem. And this says that if we can prove that all 3 sides of one triangle are in proportion to all 3 sides of a second triangle, then the 2 triangles are similar. So it's all about proportions for the sides. That's a big deal. It's got to be proportional. And then finally, there's kind of a hybrid of these two. If we can prove that 2 angles are congruent, one set of congruent angles, and the sides surrounding those angles are congruent, are proportional, gosh, I almost said congruent, are proportional, then that's enough to prove similarity. So check this out. Here we've got angle or side AB is proportional to side DE. They're obviously not congruent. And then side BC is in the same ratio as EF. And then side AC is in the same ratio as DF. Okay, well, same idea over here, but look at where the side measures are. Side AB and DE have the same ratio as side AC and DF. And very important to see that that angle is connected between them. We've seen SAS before, but now we have to look at it in terms of similarity. So here's our 3 postulates and theorem involving triangle similarity. We can work this very similar to triangle congruence. We can look at a similarity statement. Once you know a set of triangles are similar, you can write a similarity statement. Let's go with triangle ABC and XYZ. Okay. Just like in triangle congruence, we can match up all the corresponding parts. Angle A corresponds to angle X. They are congruent measures. Angle B corresponds to angle Y. They are congruent measures. And angle C corresponds to angle Z. They are congruent measures. Okay, so angles are congruent. Angles are congruent. Sides are proportional. So look at how we're going to fill out the second part of this statement here. It's not a set of congruent sides. It's a set of proportional sides. So AB in the first 2 positions would be within the same ratio as XY. Side AB can be compared to XY. Side BC in the second and third position can be compared to YZ. and side AC in the first and third position can be compared to XZ in the first and third position. So the order does matter on your similarity statement. You have to match up all the corresponding parts. It's really important. All right. You want to see a little bit of this in action. Here we go. It says use the similar statement to solve. We're looking at algebraic solving methods here. On the left, we've got triangle BCD is similar to triangle BEF. Solve for y. Now, similarity does not mean equality. It means congruent angles, proportional sides. Okay, so let's match some stuff up. Angle B congruent to angle B. Let's look at the picture. Well, angle B is in triangle BCD and angle B is in BEF. It's in the same position. That's a reflexive angle. All right, how about angle C congruent to angle B? Now, angle C and BCD is here. Angle E and BEF is here. And then finally, we've got angle D congruent to angle F. Now, I call this stacked triangles, and sometimes this is really hard to see. So I do recommend that if it's difficult for you to work with one triangle inside of another triangle, go out to the side and just redraw them. Okay? This would be B, D, C. And this would be B, F, E. Okay, maybe that helps out. Our mission here is to solve for y, and y is represented on a side value. Okay, so y is between F and E. All right, and it looks like it's between the blue and yellow angles, so it makes sense that it would match up with 8, which is also between the blue and yellow angles. Now, our triangles are not congruent. Y does not equal 8. It is proportional to 8. So we can set it as a ratio pair. We have to find something else to set it equal to. Well, if I'm going triangle versus triangle over here, I need to know how long B to F is. B all the way to F would be 10 plus 9 for 19. And I need to know what B to D is, which is just 9. So when I set up my ratio, y versus 8, I can also use 19 versus 9. Okay. Y and 8 are corresponding pairs. 19 and 9 are corresponding pairs. I'm working from the larger triangle to the bigger triangle. So the top of my proportion represents the larger triangle. The bottom of the proportion represents the smaller triangle. The left half of this equation represents the horizontal pieces, and the right half of this equation represents the left side of the triangle. So everything's categorized in the proportion. Large triangle on top, small triangle on bottom. Horizontal piece on the left side of the triangle on the right. Now I can set up my cross multiply. 9 times y equals 19 times 8. I'm going to pull out my calculator here. 19 times 8 is 152. And then divide by 9 on both sides. And I get 16.8 repeating. 16.8 repeating for y. Take the time to draw the picture if you need to, guys. You don't need to do everything in your head. Draw it out, set up your equation, make your algebra very clear so that you know how to solve. This second picture is much more laid out so that you can compare the sides that are corresponding. Let's take a look. Given triangle ABC is similar to DEF, solve for X. I'm going to start matching up my parts here. A matches with D, angle A, angle D. B matches with E, angle B, angle E. And C matches with F, angle C, angle F. So not only are the two triangles similar, but the picture has been drawn in such a way that all the angles are in the same position. This should make it really easy to see what can be compared. My job is to solve for X. X is over here on the right side of the small triangle. It can be compared to the right side of the large triangle. X is between the blue and pink marks. 39 is between the blue and pink marks. They're a match. Now I have options on what I want to use next. I could use 30 and 45, or I could use 28 and 42. It does not matter which ones I want to use, so I'm going to use 28 and 42. Now when you set up your proportion, be very careful here, okay? The top of our proportion, the X, came from the small triangle. So 28 has to be from the small triangle. 39 came from the large triangle. So 42 has to also come from the large triangle. Okay. This side of the equation are the corresponding parts. X and 39 came off the right side of the triangle, where 28 and 42 came off the bottom of the triangle. So everything's just got to be matched up and categorized before you even begin the algebra, okay? Now I can set up my cross multiply. X times 42 is 42x. 39 times 28, I need a little help with my calculator. 39 times 28 is 1092. Solve for x by dividing. 1092 divided by 42 is 26. Okay. So in order to solve side measures, we have to use proportional parts. Find what's proportional to each other, set up a logical equation, keeping everything organized, cross multiply to do the algebra. Let's take a couple more examples here. My next set of examples, or my next example, is all about angle measure. So rewind a second. Look at our notes here on similar triangles. Triangles are similar if their angles are congruent. Triangles are similar if their sides are proportional. So in this example, we're working on angle measure. So we need to be using congruence. Angles are congruent. So I've got my similarity statement here. I'm told that angle A and angle D are a match. They're congruent to each other. Angle B and angle E are a match. They're congruent to each other. And angle C and angle F are a match. They are congruent to each other. So if I'm given angle A is 80 degrees, I also know angle D is 80 degrees. If I'm given angle E is 55 degrees, then I also know angle B is 55 degrees. The job is to solve for the measure of angle F. Well, the measure of angle F is going to be whatever the measure of angle C is. What I know about triangles is all three angles must sum up to 180 degrees. So if I start at 180 degrees and subtract away the angle measures I already know, the leftover is going to give me that missing angle. So 180, take away 80, take away 55 leaves me with 45 degrees for angle C and for angle F. So the measure of angle F is 45 degrees. Now we have done that before with congruent triangles. Angles are no different for congruent triangles or similar triangles. The angles are equal. Now, our fourth and final example here is back to the side measures. Ultimately, here on the fourth example, we're solving for side ln. So when you're back in side measures of similar figures, your side measures are proportional. Sides are proportional. Okay, I'm making a big deal about that because a lot of students get stuck in a rut of wanting to set everything equal to each other, but we've got to use the correct style of solving. Obviously, these sides are not equal to each other. One triangle is much smaller than the other. Okay, first of all, use your triangle similarity statement. Match up the congruent angles so that you can be really sure what is allowed to be compared. I've got angle A congruent to angle L, angle B congruent to angle M, and angle C congruent to angle N. All right, so now it's pretty clear to see that this side measure of 5 between the blue and yellow angle can be compared to the side measure of 10 between the blue and yellow angle. So 5 over 10 is a great ratio to set up. Okay, that means the larger triangle is twice as big as the small triangle. Now my job is to solve for ln. Okay, ln comes over here on the larger triangle between the yellow and pink angle. That's on the larger triangle. Notice I set this up as small versus large. Small triangle on top, large triangle on bottom. So when I write in that 3x plus 3, I want to make sure it's on the large triangle position. It can be compared to the x plus 5 that's between the yellow and pink side. Now this is already a tougher algebraic setup, okay? Look at what you've got. 2 x's in the problem here. So when you do your cross multiply, make sure you write it all out so you can see what's going to happen. I'm going to do 5 times the entire denominator, 3x plus 3, and 10 times the entire numerator, x plus 5. And what's going to happen here? We're going to need to distribute. Okay, 5 times 3x is 15x. 5 times 3 is 15. 10 times x is 10x. 10 times 5 is 50. We've got a situation where there are x's on both sides of the equal, so I need to combine the x's to one side. I'm going to move the 10x to the left. If the x is on the left, I want to move the numbers to the right, so I'm going to subtract 15 and bring it to the right side. 50 take away 15 is 35. I've got 5x equals 35. Divide by 5 on both sides. X is equal to 7. Now, that's not the question. Don't circle 7. Don't use 7 as your answer. The question is solve for ln. So bring that 7 on up here. 3 times 7 is 21, and 21 plus 3 is 24. 24 is my final answer. ln is 24. Okay, I know this is a rather long video. There's a bunch of examples here. I've got 2 more examples for you. No problem solving to do here. What we're asked to do is write a similarity statement and a proportion comparing all 3 sides. So take a look at what's given to you. You have the picture here. Okay, we know that angle R is congruent to angle U by the picture. I also know there's a set of vertical angles in there. So I know that two angles are congruent. That's enough for me to know that these triangles are congruent. Remember, two angles is enough to know that the triangles are similar. I'm going to write up my statement here. I've got angle R equals angle U. Angle X is congruent to itself, so that leaves angle T to match up with angle S. So now I can break it all up, write out my proportion for side measures. I'm going to start with RX matching UX. Now I can do XT matching XS. And then the first and third position, RT matching US. Okay. That one's pretty straightforward, I believe. You match up your angles, you break it apart, and write out your proportional sides. This one's a little tougher. Check out that picture. It's one of those stacked triangles. Here we're told that MQ is parallel to NP. Now, what does that do for us, having parallel in there? Well, if you go way back to our study on parallel sides, we know that parallel sides can create corresponding angles that are congruent. Corresponding angles that are congruent. So corresponding means in the same position. So here I've got two sets of corresponding angles that are congruent. If I break that apart into the two triangles, I've got triangle LMQ, and then the larger triangle LNP. And now I can redraw in my congruent parts. Angle M is congruent to angle N. Angle Q is congruent to angle P. It'll be very easy for me to write up what's the match. Angle L is obviously congruent to itself up here. It's a reflexive angle. So I'm going to say L matches L, M matches N, Q matches P. Let's start breaking it apart. Side LM is in the same position as side LN. Side MQ is in the same position as side NP. And finally, side LQ in the first and third position is in the same corresponding spot as LP. So this is an extended proportion that represents the similarity of the triangle. Thank you for watching. Our next video is going to go into more detail about the coordinate methods. Come back for that if you need help.